Kinetic theory of matter. In kinetic theory of matter, we will discuss about their molecular arrangement, we will discuss about their motion, how they are moving in matter, how particles are moving. Fine. So kinetic theory of matter was developed around about 200 years ago. About 200 years ago, this kinetic theory of matter was developed by the scientist. Which scientist? Dalton, Joule, David, Maxwell, Boltzmann. So these are some scientists which discovered the kinetic theory of matter. And this question, this kinetic theory of matter is very important from exam point of view also. It is having 7 to 8 points that we are going to study one by one. So first main postulates of kinetic theories are as follow. First main point we are having, every matter is made up of tiny particles called molecule. As we have learned that each and every matter is made up of tiny particles. So that tiny particles are known as atoms as well as molecules. Because 2 or more atoms are going to give molecule. So every matter is made up of molecules. Second, molecules of a substance are identical in shape, size and mass. If I am having one substance, if I am having here for example table, so whatever particles are there in this table, the size, shape or mass of that molecules in a substance are same. Okay, whatever particles, whatever molecules are there in this table, so that all particles are having same shape, size and mass. But if I am having two different substances, one table I am having, for example, one small table or chair I am having, these particles are having their different arrangement or different size, shape, and these particles are having their different arrangement. So, according to the substances, we are having different mass, size, shape, and composition of particles. Next, we are having third point. Molecules are continuously in a state of random motion. Whatever matter we are having, for example, we are having table, chair, water or perfume, anything we are having, each and every matter is made up of some particles, or we are having molecules. So in each and every case, these molecules are in a continuous state of random motion. So motion of molecules is different in different states of matter. See, in this case of solid, motion of the particles are different, but in liquid motion of particle is different, as well as in gas the particles are in different state of continuous motion. Fine. So these motion of the molecules is varying from matter to matter. Fine. Next we are having next point, fourth point. The motion of molecule increases with increase in temperature. As we are increasing the temperature of any substance, for example, here I am having the water in a beaker, and if I am giving temperature to this water, so firstly these molecules are having their random motion, they are moving here and there. But when I am giving more and more temperature to the water, the motion of the molecule start increasing. So due to this increase in the molecule of the motion, it means that with the increase in the heat, the motion of the molecules also increases. And same with the decrease. If we decrease the temperature, with decreasing the temperature, the motion of the molecules also decreases. Next we are having, due to molecular motion, the molecules of substance possesses kinetic energy. Whenever in any state of matter, when molecules are randomly moving here and there, what does it mean? Means the molecules are in which energy? Kinetic energy. So these molecules are having kinetic energy. Kinetic energy of the molecule increases with increase in temperature. That is same above point. Like if we are giving temperature to any state of matter, to any substance, when we are giving the heat, the kinetic theory of that molecule or kinetic energy of that molecule increases. Fine. Next we are having sixth point. The molecules of a substance have space between them. Whatever state of matter we are watching, for example, here I am having solid, here I am having liquid, and here I am having gas. So the molecules of a substance, these molecules of a substance are having some space in between it. And this space between the molecules of substance, this space is known as intermolecular space. Intermolecular space. Fine. So this intermolecular space is very much least in solid, and intermolecular space is there, means some spaces are there in liquid, and intermolecular space is least in the gases. Fine, so here it is written the same. The intermolecular space is maximum for gaseous state and minimum for the solid state. Why? Because in solid, molecules are closely packed. If two molecules are very close to each other, means here intermolecular space is minimum, and here molecules are very apart from each other. One molecule is here, one molecule is here. So here molecules are having too much space between them, means the intermolecular space is maximum. Next point we are having, molecules attract each other is called intermolecular force of attraction. If I am having any like matter, here I am having a solid. So in each and every state of matter, molecules are always attracting to each other. Molecules are always attracting each other with which force? With the intermolecular force of attraction. The force present between the molecules of the matter or molecules of a substance, that force is known as intermolecular force of attraction. And these forces of attraction are of again two types. What are these two types? Force of cohesion and second is force of adhesion. We are going to study one by one about these types also. So forces are of two types. What does it mean? See carefully. For example, here I am having a water in this glass. These water molecules, here see, water molecules are having in this beaker, water molecules are there, and in water molecules particle arrangement, for example, is like this. Okay, if the force of attraction is there between the particles of same molecules, for example, water is there, here water molecule, here also water, here also water. So if the force of attraction is there among the same molecule, this is also molecule water, this is also molecule of water, here also, if they are having same molecules of a substance, then this is known as force of cohesion. But what do you mean by force of adhesion? See carefully. In this beaker, if water is there, means water is retaining in this beaker. Water is not moving here and there. Water is not going anywhere. Why this water is not going anywhere? Because these water molecules are having some force with the glass. So these water molecules, if are having some force with the glass, that is why these molecules are not going outside. So this force of attraction between the two different substances, one water molecule is there and one glass is there. So whatever force is present between the molecule of water and this substance glass, this force of attraction between two different substances is force of adhesion. Clear? Again I will repeat for you. If in the, like here water molecules are there, here all inside the beaker water molecules are there. The force between the same substances, same water molecules, this is force of cohesion. But if two different substances are there, one water is there and one glass of beaker is there, so that two like substances are having force. If the force is between the two different substances, then we are having force of adhesion. Next we are having the magnitude of intermolecular force depend upon nature of molecules of given substance. The intermolecular force also depend upon given substance. If we am having here solid, so in solid particles are closely packed. Particles are very closely packed. If particles are very near to each other means the force of attraction between the particle is very much strong. But in the liquid, particles are far away from each other, means particles are having at some distance. So due to this distance, due to intermolecular space, intermolecular force of attraction is little bit weak as compared to solid. But if I talk about the gases, in gases spaces are very much high. The intermolecular spaces are too high in the gases. Due to this more intermolecular space, force of attraction between the particle is very much least. Fine. If particles are very close to each other, very close means force of attraction is very much close. If like in liquids, particles are away from each other, intermolecular force of attraction is little bit least. But if particles are very away from each other, then force of attraction is also very least. Fine.